Welcome to the next session of video class. This video contains the explanation on statically determinate beams and indeterminate beams, also the explanation on the space diagram and free body diagram of the figure. Next, coming for the difference between statically determinate structure and indeterminate structure. First of all, we will see what is the definition of both. See, in this figure, a beam AB is given and it is hinged connection here, roller connection here. If it is hinge connection, there are two reactions. I'll take it as RAY and another one RAX. Okay. So here roller means one reaction RAV. So once I have written the reaction, you just count number of reaction here. One unknown reaction, 1, 2, 3. These three reaction I have to find out. So number of unknown reactions, known reactions, which I'll take it as NR is equal to 3 here. So you know that this is an example for coplanar non-concurrent force system. By the forces itself, it doesn't pass through a single point. So number of equation of equilibrium that you have is nothing but 3. That is sigma h is equal to 0, sigma v is equal to 0, sigma m is equal to 0. So I'll take that number of equilibrium equation as NQ. So if you have number of unknowns reactions is equal to or less than number of equation to be solved, then it is called as statically determinate structure. Or else in other way you can say, if the number of unknown reactions present here is being able to find out by using the condition of equilibrium only, then that particular structure or beam can be considered as statically determinate. So NR is equal to NQ here, so it is an example for statically determinate. Or else if NR is less than this value, again see in the figure itself, 3 unknowns are there, 3 equations are there. So these 3 unknowns can be found out by using these 3, correct? If the reaction is nothing but less than that, that is 2. Again 2 unknown reactions can be found out by using this 3 equilibrium condition. If at all one unknown also, it can be found out. So if it is more than the number of this equation of equilibrium, then it is considered as the next type, that is statically indeterminate. So here in the beam you can see a beam here, it is fixed. So how many reaction? RAY, RAX and a moment, I'll take it as ME. And here it is hinged RBY and RBX. How many unknown reaction? That is NR. 1, 2, 3, 4, 5. 5 NRs are there. Again, if you see all those forces, it is again a coplanar non-concurrent force system where you have NQ, that is number of equilibrium equation. Again, the same thing, that is 3. So using these 3, number of unknown cannot be found out. Only 3 unknown reaction can be found out. The other 2 will be the extra, where you may require extra equations to be found out for solving other 2 unknown reactions. So in this case, if NR is more than NQ, then it will be example for statically indeterminate beam. If at all they ask in the form of what is difference between statically determinate structure and indeterminate structure, you can write the definition, provide one example, and you can show the equation difference. That is, here it is NR less than or equal to NQ. Here it is NR greater than NQ. See, whatever the number of extra unknown here is nothing but number of indeterminates. It is called as number of indeterminates. So here it will be always number of indeterminacy is nothing but equal to 0. Here it will be extra number of unknowns which cannot be found out by only equilibrium conditions. So that is another difference. So if they ask for the similarity, both the cases are an example for coplanar non-concurrent force system. So number of equilibrium condition will be equal to 3 itself. Next, coming for the concept space diagram and free diagram. See, till now I have represented a beam with the hinged and hinged and a UDL. If at all you represent the support in the form of how it is represented and UDL in the form of how it is represented and it is not reduced, then this diagram is called as space diagram, or a diagram of the structure that indicates its form as well as means of its support and loading condition. The diagram is indicating its own beam form and support and loading as it is, then it is a space diagram, wherein if that particular beam is, that means you know that this is a hinge, one reaction, another reaction, this is a hinge, one reaction, another reaction, and this UDL is converted into point load. That means it is acting onto this portion itself. So it is acting for 2 meter. It should be at the middle, that is 1 meter from either the side, that is C and D. Then intensity is nothing but 10 kilonewton per meter into 2 meter. Meter get cancels. 10 kilonewton into 2 is nothing but 20. So this UDL is converted as point load. This support is converted as reaction. So in this figure you can see that all the reactions or whatever the point load you are writing, it is in the form of force. So a drawing used to show the relative magnitude and direction of the forces acting upon the object, then you can call it as a free body diagram. So if at all I have to call it as a free body diagram, all the terms and conditions should be represented in the form of magnitude and direction of a force. So if at all one or the other is not converted, still it is not a complete free body diagram. So you have to convert supports into reactions, which is form of force, UDL into point load, which is a form of force, again here support into forces, so that I can call complete diagram as a free body diagram. So these are the theory things whichever you have to study in module 3. In the next class we will deal with the problems for which these theory things you have to remember. The main thing whichever we have to remember is types of supports. Simple support, where one simple support will be having one upper reaction. Roller support, again one upper reaction. Fixed support means 2 reaction. Hinged support means 2 reaction. Fixed support means 2 reaction in this way as well as a moment. So representation of simple is the same thing, one reaction. A roller, it may be a circle or like triangle with a circle. Hinge, it may be a point triangle or a point triangle and a hash, or a triangle and a simple hash. Here it may be one triangle. So here it is only one representation, like one and a hash, a line and a hash. So this representation as well as how to convert it as a reaction you should be remembering, and how to convert UDL, UVL into point load you have to remember. Anyways, the problem we will see in the next class. But while solving, it will be always a example for statically determinate structure determinate structure, and it will be always a example for coplanar non-concurrent force system, where you have equilibrium condition. Number of equilibrium condition is 3. So using these 3 equation itself, you can find out all the unknowns. Thank you.